Let's try to explore how to find slope of a tangent line to the parabola. Here is an example. Example 1 says, find the slope of a tangent line to the parabola y equals to x square at x equals to 1. So that's x equals to 1 and the point is marked here in orange. Let's call this point as P. So let this point be P. Now, to find slope of a tangent line, we need 2 points, but we are only given 1 point. How do we get the other? So what we will do is, as we saw in the previous video, we can take some other point on the curve. So let's take a point here, point Q, and let me call this point as Q. Correct? Now if I draw a secant from P to Q or from Q to P, joining P and Q, I get slope of the secant. So that's my line joining P and Q, and it looks as if the slope of P and Q is 1. So this is rise of 1 and run of 2. Well, this is definitely not the slope of tangent line to the parabola at P, which seems to be much steeper, right? You can see that. So what we can do is, we can approach Q, can come closer and closer to P. As Q comes closer and closer to P, the slope of the secant approaches the slope of the tangent. And that is how we can get slope of the tangent, right? So let me repeat. In the last video, we said that the slope of the tangent line is the limit of the slopes of the secant line as the point Q approaches point P, right? So this is the concept we learned in the previous video. And here we are going to use this concept to find slope of the tangent line. So this is how we do now. So basically, to find a slope, let's say we want to find slope between 2 points, which are P and Q. So we can write slope between P and Q is equal to y2 minus y1 divided by x2 minus x1, where x1, y1 and x2, y2 are 2 different points on the curve, correct? On your graph. Now, we know 1 point, which is 1, 1. So the point P is 1, 1, right? But the other point, what we will do is, we just take random point close to P, and then we will bring this Q closer and closer to P, and then figure out what the slope is. Okay, so basically we have 1 as y1 is 1, 1. So we have y2 minus 1 divided by x2 minus x. X is also 1. So that is the slope at 1. Now how to get these points? So what we will do is, we'll make a table of values. For different values of Q, at present the point Q is 0, 0, correct? So as we bring closer and closer, point Q will change, and thereby the slope will change, and we will notice what kind of change is there on the slope. So what we will do is, we'll make a table of values. So here is the table, and we will write the values where x is less than 1 but closer to 1. Okay, so we will use x values here and the slope MPQ on this side. Correct? We'll calculate using y2 and y1. Remember, the equation is y equals to x square. So we know y2 if we know x2, right? So I could write this as x2 square minus 1 divided by x2 minus 1, correct? So that is what my point is. Now, where this point I'm saying is x2, y2, correct? I could have written xy in general because this point is fixed, 1, 1, okay? I write x equals to 0, then this is 0, 0 square is also 0, 0 minus 1 divided by 0 minus 1 gives me a slope of 1, which we can clearly see. Now, we can have other values of x, and we say, well, let x approach 1 from the left side. That means, actually speaking, x is less than 1. We are approaching from the left side, okay? So we can write, let's go here. So we can take a point here. That means we get that point, which is, let's say, 0.5. So if I have 0.5, let me calculate the value. That means 0.5 square minus 1 divided by 0.5 minus 1 gives me the slope of the secant where q dash is at 0.5. Okay, so let me calculate that using a calculator. So we get 0.5 square minus 1 divided by 0.5 minus 1. That gives me 1.5. So let me write down 1.5. Now let me take another point which is very, very close to this, and let this point be 0.1. Mind it, it cannot be 1, right? It has to be closer to 1. So when it is 0.9, then I get 0.9 square minus 1 divided by 0.9 minus 1. And if we calculate this, we get 1.9. So that is 1.9. And now let's try another value, very close to it. Let it be 0.99. Now if we calculate with 0.99, what do we get? We get, it is 1.99. We can go even closer. So the beauty of algebra is that numbers, you can go very, very close to 1 and let it be 0.99 lines, 3-digit accuracy, right? So when you do that, then you get answer as 1.999. So that is the slope. So we can see from here very clearly that the slope is changing from 1 to 1.5 to 1.9, 1.99, 1.999. So it is kind of approaching 2. Do you see? So we can say that these are all the secants, right? Because they are two different points. A line joining two different points is a secant. And slope of the secant is actually increasing. Do you see? The slope of the secant as you go increasing, and it is heading towards 2. Do you see that? So if you move from left to right, this point becomes closer and closer. Q becomes closer and closer to P from left to right. We see that the slope increases from 1 to 2. So that could be the slope of our tangent. To be doubly sure about it, what we can do is we can take a point on the right side. Do you understand? And approach from there. Okay, so let's make another table of values. This time, let me write it in a different ink. So we'll do x points here and the slope m from P to Q. And this time, we will choose points on the right side of x, which is, let's say 2. So let's start with 2, right? So at 2, we'll plug in 2 here. So 2 square is 4, 4 minus 1 is 3, 3 divided by 2 minus 1, which is 3. So we get a slope of 3. That is, I just took a point here and I say, well, I've taken a random point which is close enough, not that close, but still here this is the point and the slope of this line is 3. So I took a point here, let me call this again Q, okay? And now I'll bring this point closer to it. Let me bring it from here to straight to somewhere here and then here and then here and then like this, right? So we will compute the slope of our secants as Q becomes closer and closer to P. And let us say we bring it to, let's say 1.5. So we have 1.5 square minus 1 divided by 1.5 minus 1. And similarly, we'll bring it to 1.1 and then 1.01 and then we'll pick 0.01. So that gives us 3-point accuracy, correct? If you compute these slopes, I've already done so, I can write down the values for you. You will get 2.5, 2.1, 2.01 and 2.001. Correct. So what your approach is, as you can see from here, at this time you're approaching a slope of 2, right? From 3. It is decreasing and it is decreasing and approaching towards 2. So you see, from right side when you approach, you are approaching a slope of 2. And from left side also, you are approaching a slope of 2. So both the secants from left and right are approaching towards one value. and that value is 2. So what we can confirm now is that the slope of the secant is, or slope of the tangent is 2. So I am drawing a tangent with slope of 2. Slope of 2 is rise here. Do you see rise and run? So I am joining these 2 points for you to show you that ultimately that becomes the tangent line to our curve, which has a slope of 2, and that is probably the closest point we can go to P. So like this you can go and get. So what we learned here is application of our concept which we developed in the previous video. That is, slope of the secant becomes the slope of the tangent as the limit of Q approaches P. So we'll write that definition once again in the limit form, and we will say here limit of Q approaching P. As Q approaches P, the slope of secant, which is from MPQ, becomes slope of tangent, right? Correct. So as you can see, we took an example y equals to x square and found out that at x equals to 1, the slope of the tangent is actually 2, right? Important thing here is we have to take a point Q, and we can approach from both sides, from left and from right. And in both ways, we saw that we were approaching a value 2. If we approach the same value from both the sides, then that means the slope of the tangent line is that value which we are approaching as point Q approaches closer and closer to P. Q should be different from P. It can be like P. Q could be 1.0001, but it cannot be 1. It can be as close as possible, but not. So the 2 points are distinct. So P and Q are 2 distinct points, with difference between them very minute. Then slope of the secant is same as slope of the tangent. Correct? So we'll explore more these concepts of limits, and by now I think you have understood how limits help us to find slope of tangent to any curve. Okay, thank you.